In this video, we'll be looking at the tangent. So the first video of this section for 10.1, we looked at sine and cosine. The second video looks at just the tangent. So as you see on your screen, this is the general graph of y equals the tangent of x. Notice there are some vertical asymptotes. Those are places that the function are not equal to. And then we have a bunch of these curves in between. Going from this negative pi over 2 and to this pi over 2, those are our two main asymptotes, and then the curve in between, that's that main first cycle like we talked about with the sine and cosine. So that'll be the one that I'm expecting you to draw. Just know that it does constantly repeat the same thing on both sides, so it just keeps on going. All of those curves being the exact same or could be found in the exact same way. So before we get to graphing them, let's look at some characteristics of the y equals the tangent of x. The domain, or what the x value can be, is all real numbers except odd multiples of pi over 2. Because if you remember, thinking back, so let's just look at our graph, every place that there is an asymptote is going to be an odd, in the general y equals the tangent of x, is going to be at an odd multiple of pi over 2. So that's our first characteristic. The second is the range. The range, remember, is the y value, so in this case, it's going to be all real numbers. Because again, looking at the graph, it just keeps going up forever, keeps going down forever. So it is all reals, meaning that there is no max or min, also meaning that there is no amplitude. Okay, so no max or min, and again, meaning no amplitude. So the amplitude does not exist on the tangent. So when asked to identify things, when it says amplitude, just say does not exist or none, because there is no amplitude on a tangent graph or tangent function. The period now is a little bit different than that of the sine and cosine. The period for sine and cosine was 2 pi. The period for tangent is just pi, because it only takes pi units to get from one asymptote to the next asymptote. And then your x-intercepts for just, again, the y equals the tangent of x. Once we start adding numbers in there, this will change. But for now, the x-intercepts can be found at 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and so on. So every multiple of pi is where an x, with the addition of 0, is where the x-intercepts are going to be found. So now when adding values in for a and b, so putting numbers in front of the tangent and putting numbers in front of the x value, the only thing that really changes is the period, because remember there is no amplitude, so we don't have to worry about that. But the period, now instead of being pi, is going to be pi divided by that absolute value of b. So just like we did with the sine and cosine, just with that one we actually had a 2 with it on top, but this case is just that pi divided by the b value, an absolute value. So keep in mind, period still will always be a positive number. And then the other thing that changes is the vertical asymptotes. So for the vertical asymptotes, like we mentioned earlier, it was odd multiples, but this case is going to be odd multiples of pi over 2 absolute value of b. So that's where your vertical asymptotes are going to be found. So when graphing, we're still going to have those 5 key points, or 5 key values, because now this time it may not necessarily be points. So with sine and cosine, we found 5 key points, connected them, and that made our graph. When graphing with the tangent, you're going to use 5 key values. Some of them will be points, others will not, but they're going to help you and guide you in what the graph of the tangent looks like. So 2 of those 5 key ones are going to be your asymptotes. So you're going to have 2, 1 on either side. You're going to have an x-intercept that, oh, too many eyes. So you're going to have your x-intercept, which is actually halfway between the asymptotes. So that there gives you 3 points. Now the other 2 are going to be found halfway between either the asymptote and the x-intercept or the other side, the x-intercept and the asymptote. So halfway between asymptote and x-intercept. And what that does is when you find that halfway again between the intercept and the asymptote, is that that's where your value is going to be either A or negative A. So that's where that A value comes in, is if you find halfway between the asymptote and the intercept, and then you can, go to either up to positive A or down to negative A. Keeping in mind, if we go back to our graph, notice the shape of the tangent, how if you find the first between the asymptote and the intercept, you're always going to be going down to the negative A value. But if you go intercept to asymptote, you're going to go up to that A value. So just keep in mind that you want that same general curve, so it's always increasing. So as you read it from left to right, the graph is going up. So keep that in mind when finding these 5 key points or 5 key values. So let's now look at an example of graphing one of these functions. And notice that this still is Learning Target 10.1a. 10.1a includes all of the graphs, and then 10.1b includes all of the functions, identifying those different parts. So we want to now do 10.1a, or the second part of 10.1a, graphing, in this case, a tangent function. So for this problem, I gave you y equals 3 tangent of 1/2 x. So the first thing we want to do is figure out where those asymptotes are going to go. So remember, if we think back, the asymptotes are going to be at pi over 2 times b. So looking at this function, my b value is 1/2. So my vertical asymptotes are going to be at 2 times 1/2, or at multiples of this. So 2 times 1/2 gives me 1, so this is just equal to pi. So that tells me when I'm graphing it that every pi is going to have an asymptote at it. So if this is pi here, then my asymptote I'm going to have here. And then remember, we always do then 1 over here because we aren't shifted it left or right any. This would be a negative pi over here. So there's my first cycle. Now, if I wanted to, I could repeat it past that and put an asymptote at 2 pi, 3 pi, 4 pi, 5 pi, or negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi, and so on. But like I told you, I only need the one main cycle. I also know that the number out front, that 3 is going to come in at some point, so I'm just going to make sure that my graph, shows the 3 and the negative 3. And then for those 5 key values, 2 of them were the asymptotes. I find halfway between that, which in this case is 0. So I'm going to go ahead and put a dot here at 0, 0. So when I do that, I have a dot there. And now I find halfway between the other 2 to find, because now that gives me 3. So to find those other 2 points, I've got to find halfway between the intercept and the asymptote. So for now, I'm just going to put a mark here and a mark here for my halfway. So I guess I could find those. So halfway between 0 and negative pi would be negative pi over 2. Halfway between 0 and pi would be pi over 2. So now I need to put in my last couple points. So we said find halfway and then use that a value, so in this case the 3. Keeping in mind also that as I go from left to right, I want my graph to be going up. So it tells me at the negative pi over 2, I need to be down at negative 3. At the positive pi over 2, I need to be up at a positive 3. So that my graph makes that curve that does go up as we go from left to right. So now I'm just going to connect those in such a way that I hit all these points, and try to make that tangent curve a little bit there. Kind of hard to make it since these points are so spread out. But just again, try to make it as best as you can. Don't make it a straight line. Show that it does kind of curve off to those asymptotes. So get that in there some way. But there is your first cycle of the tangent. And that's, again, all I expect you to do. Now, again, with this one also, Learning Target 10.1b has you identifying different things in the graph. One of them being the period, which I guess we didn't calculate before, but the period, remember, is the pi value divided by b, which in this case is going to be the b value is the number in front of x, which is a half. So then when I do my leave change flip, I get the period is 2 pi, which to double check on my graph, the distance between two asymptotes, so negative pi all the way to positive pi is 2 pi. So that gives me my period. The x-intercepts, in this case there is only one. In this case is also, or is going to be at 0, 0. That's this point here. And then the only other thing I have to identify on tangent functions is vertical asymptotes. Oops. So we found those earlier to be at the pi over 2 times b, which in our case was pi. So the first two here are just going to be at a positive pi and a negative pi. So those are the things that I need to identify for my Learning Target 10.1b when looking at tangent. Notice that there is no amplitude, so if they ask for amplitude, we would put none. And mins and maxes also, there are none because that graph keeps going up, keeps going down, so there is no min or max value. So again, if they ask for it, you would just say that there are none mins and maxes and no amplitude.